Entropy and its dimensional formula. Entropy of a thermodynamical system and its dimensional formula. And its dimensional formula, that is entropy and its dimension. Entropy and its dimension. This is a thermodynamical system which consists of an ideal gas. This thermodynamical system consists of an ideal gas of pressure P, volume V, absolute temperature T, and heat energy of the ideal gas is Q. And we consider small amount of heat energy, that is delta Q, is supplied to the thermodynamic system. Delta Q is the small change in very small change in heat energy, a small change in heat energy of the thermodynamical system. The change in entropy of a thermodynamical system, the change in entropy under bracket ds of a thermodynamical system is defined as the ratio of a thermodynamical system is defined as the ratio of change in heat energy to the absolute temperature of the thermodynamical system. The change in entropy ds of a thermodynamical system is defined to be the transfer of heat energy, that is delta Q, and it is denoted by delta Q because heat energy does not depends upon the nature of the path, and delta Q is imperfect differential. So the change in entropy is defined as the transfer of heat energy under bracket delta Q into the system divided by its absolute temperature, that is ds is equal to delta Q by T. ds, that is change in entropy of the thermodynamical system, is equal to delta Q by T. ds is equal to delta Q by T, which is the change in entropy of the thermodynamical system. Unit of entropy. Unit of entropy is joule per Kelvin. Unit of entropy under bracket capital S is joule per Kelvin. We know that change in entropy ds is equal to delta Q by T. Delta Q is the small amount of heat energy applied by the thermodynamical system, and delta Q has the unit joule, and absolute temperature T has the unit Kelvin. That's why unit of entropy will be joule per Kelvin. Joule per Kelvin. Unit of now ds is joule per Kelvin. Unit of ds is joule per Kelvin. Now if we find the dimension of ds, that will be dimension of delta Q by dimension of T. Now dimension of delta Q is equivalent to dimension of heat energy, which is ml square T to the power minus 2, and dimension of T divided by dimension of T means it should be divided by dimension of temperature, that is K. Finally we get the dimension of delta ds, dimension of ds as equal ml square T to the power minus 2, ml square T to the power minus 2 divided by K divided by Kelvin. The dimension of ds is equal to ml square T to the power minus 2 Kelvin inverse, which is the dimensional formula of entropy. Dimension ds is equal to ml square T to the power minus 2 Kelvin inverse, which is the dimensional formula of entropy, that is the change in entropy, that is the dimensional formula of change in entropy. So the dimension of change in entropy or dimension of entropy is ml square T to the power minus 2 Kelvin inverse. Dimension ds is equal to dimension ml square T to the power minus 2 Kelvin inverse, which is the dimension of entropy under bracket S. Hence the dimension of entropy is ml square T to the power minus 2 Kelvin to the power minus 1 or K to the power minus 1. Finally we get the dimension of entropy S as ml square t to the power minus 2 k inverse. Significance of entropy. What will be the significance of the physical quantity, or the significance of entropy? Significance of entropy. The significance of entropy is, that means here we can say that the entropy is a scientific concept. Entropy is a scientific concept that is also a measurable physical quantity. Entropy under bracket S is a scientific concept as well as a measurable physical quantity, physical quantity or property of a thermodynamical system. Entropy is a scientific concept as well as a measurable physical quantity or property of a thermodynamic system. Also, entropy is directly proportional to the logarithm of number of microstates of the thermodynamic system. Entropy is directly proportional to the logarithm of number of microstates of the thermodynamic system. Therefore, entropy is proportional log base e omega. Therefore, S is equal kb log base e. S is equal to kb. K subscript b is Boltzmann constant log omega. S is equal to kb log base e omega, where omega is the number of microstates of the thermodynamic system. We get entropy as equal kb log base e omega. Therefore, S is equal to kb ln omega. Ln means ln is equivalent to log base e. Entropy S is numerically equal to the product of Boltzmann constant kb, and logarithm of ln of number of microstates. Therefore, S is equal to kb ln omega. That means S is numerically equal to the product of Boltzmann constant kb and ln omega, which is entropy, where omega is the number of microstates. Omega is the number of microstates of the thermodynamic system. Omega is the number of microstates. Omega is the number of microstates of the thermodynamic system. Microstates of the thermodynamic system. S is equal to kb ln omega, which is the entropy of a thermodynamic system. S is equal to kb ln omega, which is the entropy of thermodynamic system, and kb, k subscript b is Boltzmann constant. Kb is Boltzmann constant having value 1.38 into 10 to the power minus 23 joule per Kelvin. Now we can find the dimension of entropy S. Dimension of S is equal to dimension of Boltzmann constant K B and dimension of ln omega is equal to dimension of KB into 1. Here as the number of microstates under bracket omega has no dimension. Omega means number of microstate is dimensionless quantity. That's why we can say that dimension of ln omega. That's why you can say the dimension of omega is 1 because omega is dimensionless quantity. Dimension of omega is 1 and dimension of ln omega is also 1. Therefore, dimension of entropy S, dimension of S is equal to dimension of Boltzmann constant Kb. Therefore, dimension of S is equal to ml square T to the power minus 2 Kelvin inverse. ml square T to the power minus 2 Kelvin inverse. That is the dimension of entropy. As the dimension of Boltzmann constant Kb is ml square T to the power minus 2 Kelvin inverse or K inverse, that's why dimension of entropy, that is the dimension of S, will be equal to ml square T to the power minus 2 Kelvin inverse. Here dimension of entropy, that means dimension of S, will be equal to the dimension of Boltzmann constant. So we can say that entropy and Boltzmann constant, that means entropy S and Boltzmann constant Kb, have the same dimensions.